Okay, you guys, we're going to start with a warm-up here. I would like for you to go ahead and graph each pair of lines and then use the slopes to tell me whether these lines are parallel, perpendicular, or neither. All right, what you should have noticed is when you graphed UV, you got the slope of 3 over 1. And when you graphed XY, you got the slope of negative 1 over 3. Well, what happens is you end up with opposite signs. One's positive, one's negative, and they're reciprocals of each other. Therefore, these are going to be perpendicular. Ooh, excuse me. All right, in this next warm-up problem, I simply just want you to use the graph to find the slope of the line. All right, what you should have noticed is that you have 2 points on your line, so you could have just traveled from one point to the other. Remember, it's rise over run. Our rise actually goes down 4, so it's negative 4, and our run goes over 8, positive 8. So negative 4 over 8 gives me negative 1/2. Now, if you would have noticed, our line actually cuts through the grid right here in a nice neat area. This is also a down 1 over 2, so you could use that to help you find your slope as well. Either way, your slope would have been negative 1/2. All right, our notes today are all about equations for lines. These are actually called linear equations. The word line is actually in the word linear. That helps you remember that they're actually graphs of lines. Some examples of linear equations are given to you, and then I also have non-examples of linear equations. And what I want you to notice is that there's 2 major rules. The first rule is the coefficients here, not coefficients, sorry, the exponents here cannot have a power greater than 1. Notice all of your examples of the linear equations. Your exponents cannot be greater than 1. Okay? The second thing you have to remember is that you cannot have a variable in the denominator here. So you can have fractions in your linear equations. So your coefficients here, like 1/2 and 3/4, these are fine. But the second you throw a variable in the denominator, it's no longer a linear equation. So no variables in the denominator. Okay, so linear equations. You can have an x, you can have a y, you can just have an x, you can just have a y, you can have coefficients that are fractions, but the 2 big no-nos are your exponents greater than 1 and your variables in the denominator. The next thing I want to talk about are x and y intercepts. X and y intercepts are where your graph crosses the x and the y axis. So if you take a look at this line here, our x-intercept here is at the point negative 3, 0. And where we cross the y-axis, which is here, is at 0, 2. So let's take a look. How do you find the y-intercept? How do you find the x-intercept? Well, let's look at our graph here. To find the y-intercept, you should notice that your x-coordinate will always be 0 because you are never moving left and right. You're only moving up and down. So your x-coordinate's always 0. Take a look at the x-intercept. Okay, if I'm on the x-axis, I'm only moving left and right. There is no vertical movement at all. Therefore, your y-coordinate will always be 0. So, to help you out here, if you want to find the x-intercept, all you have to do is make y equal to 0. If you want to find the y-intercept, all you have to do is make x equal to 0. Follow these rules and you'll be good to go. Alright, so this next problem asks you to find the x and the y-intercepts and the slope of this equation and then graph the line. Well, let's start with our x-intercept first. Remember our rule, if I want to find the x-intercept, you have to make the y 0. So we're going to use this equation, 6x plus 4 times, in this case it's got to be 0, equals negative 24. And we're going to go ahead and solve for x. Well, 4 times 0 is 0, so you get 6x equals negative 24, leaving you with x at a negative 4. So let's plot this. X-intercept is at negative 4. If I want to find the y-intercept, you guys, remember x has to be 0. So let's plug that in. 6 times 0 plus 4y equals negative 24. 6 times 0 is just 0, you guys. So 4y equals negative 24, leaving you with the y-intercept of negative 6. So let's plot that. Unfortunately, this one's going to go off a little bit, but there we go. How many points determine a line? 2 points determine a line. So let's draw our line through. There it is. So we have found the x-intercept, the y-intercept. We've graphed it. The only thing that we have left to do is go ahead and find our slope. Well, here's my 2 points. The x-intercept's at negative 4, 0. The y-intercept is at 0, 6. Sorry, negative 6. So let's do our slope. y2 minus y1 all over x2 minus x1. I'm going to use green. So we'll have negative 6 minus 0, and 0 minus negative 4, which gives you negative 6 over 4. Your slope, you guys, is negative 3/2. All right, the last thing I want to talk about is your horizontal and your vertical lines. Your horizontal line here shows that the horizontal line is a y equals equation, meaning, excuse me guys, this line will cut through the y-axis, and the point on the y-axis is actually going to be our y-intercept. So it is a y equals line. In this case, it's y equals 2. And I want you to take a look. Does this line ever cross the x-axis? Unless it is the x-axis, no, it doesn't. Now, if I want to write down what the x-intercept is, I can't write down that the x-intercept is at 0 because clearly this line does not cross at 0. So in this case, there is no or none for the x-intercept. However, the y-intercept clearly does cross through the y-axis, and that's here. So the y-intercept is going to be at 0, 2. Now, if we take a look at our vertical lines, over here, a vertical line is an x equals equation. Sorry, guys, didn't mean to do that. It's an x equals equation, meaning it's a line that cuts through the x-axis at a certain point. That certain point is your x-intercept, and in this case, the x-intercept is at 3, so we're going to put a point at 3, 0. And I want you to notice that here is your vertical line, or your y-axis. Does this line ever cross the y-axis? No. And again, you can't say that the y-intercept is 0 because clearly it doesn't cut through 0. So the y-intercept, there would be none. So just a preview, or review, I should say. A horizontal line is a y equals equation that has no x-intercept unless it has the x-axis itself. A vertical line is an x equals equation that has no y-intercept unless, of course, it's the y-axis itself.
So now we're going to take a look at the different types of equations for lines, and there are actually 2 of them that we're going to cover. The first one you've covered before in algebra, and it's the slope-intercept form. And a slope-intercept form is in the form of y equals mx plus b. Now, what do these things stand for? Well, when you're dealing with slope-intercept form, the y and the x will always remain y and x. There's no changing that. However, this m here, as what we've known from before, working with it, we're talking about the slope. So m represents the slope of the line, and b, which might be a little bit different than what you've seen before, is actually the y-intercept of our line. So wherever the line crosses the y-axis at 0, what that number is, we're going to put that in for our b. So y equals mx plus b is our slope-intercept form. Now, a couple special cases occur, and they occur with those horizontal and vertical lines. And remember what Mrs. Flanagan said. If you're dealing with a horizontal line, it's a line in a y equals b, or y equals some number type of equation. And the b represents the y-intercept, because if you're thinking about the horizontal line and it crosses, where it crosses is actually your y-intercept. So that's why it's y equals b. And the other thing, too, is you notice that it's got a slope of 0, because horizontal lines have slopes of 0, which makes sense, because if I did y equals 0x plus b, that's why we really don't talk about this 0x, because 0 times anything ends up giving me a 0. That's why it's y equals b. Vertical line, however, is a little awkward. It's an x equals equation. Don't worry about the fact that it says a. It's just representing any number that I can have. And the reason why it has to be an x equals is because the slope is undefined with a vertical line. Therefore, I can't shove a number in for my slope and get anything out. And normally, when you're dealing with a vertical line, there is no y-intercept. So it kind of breaks the mold for the slope-intercept form. So remember, horizontal lines are y equals b, and vertical lines are x equals some number. So using what we just learned about the slope-intercept form, we're going to go ahead and try to name the slope and the y-intercept of the following line. And the line is y equals 3/4 x minus 2. So if I'm looking at this, it is indeed in the form of y equals my mx plus b. So my m, I'm looking for the number next to my x, and the slope of this line ends up being 3/4. And the y-intercept, however, that we're looking for is going to be this last value on this equation. So instead of being a plus, it's actually a minus, so that means my y-intercept is going to be a -2. You can write it as that, or sometimes we like to see it as a coordinate, so 0, -2. Now, using your information about slope-intercepts, why don't you go ahead and try the next example. I want you to write the slope-intercept equation when I give you the slope is a -5/2 and the y-intercept is 3. Alright, so hopefully you ended up getting something that was a y equals a -5/2 x plus 3, because the slope was a -5/2 and the y-intercept was a 3. Nice and easy. Next example, what I want you to do is I want you to try changing this equation into slope-intercept form. And I don't know about you, but you realize that with slope-intercept, it's always a y equals, and then the x's come first. So try to get this equation to be a y equals equation. Try it on your own, and when you're ready, continue the video. Alright, so the first thing I gotta do to get this y by itself is I'm going to subtract the 3x from both sides. Whoop, back her up. Gotta get rid of that. Let's try this again. So I get -6y equals a -3x plus 12. The reason why I put that x first is because in my slope-intercept form, it is y equals mx plus b. I want the x's first. So then afterwards, I go ahead and divide everything by a -6. And when I divide by a -6, I get y equals 1/2 x minus 2. So that's my slope-intercept form. So in this example, we're going to try to graph out an equation. And the equation, hopefully you notice, is written in slope-intercept form. And when it's written in slope-intercept form, it's actually nicer to graph it because of the fact that you can just go ahead and pull the y-intercept and its slope right away. So the first thing is you're going to graph this out by pulling out the y-intercept. And we know that the y-intercept in this case is a +4. So my y-intercept was a +4, so that means I'm going to go up on my y-axis to 4 and plot a point. So that's the first thing you do, plot your y-intercept. Then the second thing you do is you figure out what your slope is, and my slope from this line is a -1/3. So from my y-intercept, I'm going to go down 1, right 3, down 1, right 3. Or I could have gone, from my y-intercept, I could have gone up 1, left 3. All you need is 2 points, though, to determine a line. So then I draw my line through as straight as I possibly can, and you're all set. The second form of writing an equation of a line would be in point slope form. Now, this might be slightly new to you guys. I don't know if you've seen this before. However, point slope form is really pretty easy. All it means is a point that sits on the line and a slope of the line. So when you write this out, I'm going to let you know that this y and this x remain the same. Those never change. However, this y sub 1 and this x sub 1 come from a point that sits on the line. And a point is always the x coordinate first and then the y coordinate. Well, notice the x's kind of stay together and then the y's kind of stay together. So it's going to be y minus the y coordinate of the point that sits on the line. And then it equals m times the quantity, m, remember the slope, times the quantity of x minus the x coordinate of the point. So what I'm going to do here is I'm going to ask you to write out an equation of a line in not only point slope form, but also in slope-intercept form. So I give you the slope of the line is -2, and I give you a point. So depending upon what I gave to you, it really tells you what you can write to the equation in what form. So if I'm looking at this, it gives me the slope and it gives me a point. Perfect candidate for point slope form. So we're going to write it out point slope form, and I'm just going to give you a refresher it was y minus y sub 1 equals m, and then x minus x sub 1. So if you're looking at this, you could actually take a look at your point, and if you want to, you can label it as x sub 1, y sub 1, in case that helps you out. And this was my slope. So I'm going to fill in the blanks. So y minus the y coordinate was 10 equals the slope, which is negative 2, parentheses x minus the x coordinate, which was a 4. So that's it. That is my point-slope form. Now, they also want me to find slope-intercept form. And to find slope-intercept form, what you have to do is you have to get the y by itself. So if I'm going to get the y by itself, I'm going to use the equation we just came up with. And the first thing I'm going to do is I'm going to take this negative 2 and I'm going to distribute it through. So I get y minus 10 equals a negative 2x plus 8. And then I'm going to go ahead and add 10 to both sides. When I do that, I get y equals a negative 2x plus 18. That is my equation, my line, in slope-intercept form. It tells me that my slope was a negative 2 and my y-intercept is 18. For this example, it's slightly different, though, because what they're giving to us now is 2 points. So if I'm looking at the 2 points, I've got 8, 6, and negative 3. And what I want to do is I want to write it in point-slope form and then in slope-intercept form. But for me to write it in point-slope form, I need 2 things. I need a point and I need a slope. Well, the point isn't a problem because I can choose these. The slope is what's causing a little bit of an issue. So what I want you to do is I want you to go ahead and say, hey, I need to find out what the slope is between these 2 points. Do me a favor, find the slope between the 2 points, and then try to write your equation in point-slope form. Now, does it essentially matter what point you choose to work with? No, it doesn't. However, for our purposes, to make sure that you're on the same page as I am, why don't you go ahead and choose the second point to use when you're writing in point-slope form. So go ahead and try that now, and when you're all set and ready, start the video up again. So taking a look at what we have now, I found the slope between the 2 points by using y2 minus y1 over x2 minus x1, and I ended up getting a 9 over 11. So if I'm writing it in point-slope form, I told you to choose a second point just because it was easier for us to make sure that we're on the same page. Could you use the first point? Yes, there's nothing wrong with that. However, you wouldn't be able to check your answer with me. So I'm taking a look at the point-slope form, and it was y minus the y coordinate, so it was minus the negative 3, that's why it's plus positive, equals the slope of 9/11 that we found, times x minus a negative 3. So this is what we have for a point-slope form. Fantastic, we leave it as is. Now the tricky part comes in when we need to figure out what the slope-intercept form is. And the slope-intercept form said, you know what you're going to do? You're going to get rid of your parentheses, and you're going to get y by itself. So what I have to do first is I'm going to have to get this 9/11. I have to work with that. Now, a lot of students have issues with fractions. So one way in which you can work with this problem is, you know what you can do? You can multiply both sides by 11. So if I took both sides and I multiplied it by 11, I would end up getting the 11s to cancel out on my right-hand side. And then my 11 would distribute through here. So I'd have 11y plus 33 equals 9 times x plus 3. Now I'm going to distribute the 9 through, and I'm going to get 11y plus 33 equals 9x plus 27. I'm going to subtract my 33 from both sides. So I get 11y equals 9x, and this will be a minus 6. And then we'll go ahead and divide by 11 then. So when we divide by 11, I get y equals 9/11 x minus 6/11. That's slope-intercept form. Now, could you originally just taken the 9/11 and distributed it through and then subtracted the 3 to the other side? Absolutely. The only issue with that is students who have difficulties with fractions see that as pretty difficult. So you do either which way. Hopefully, though, you end up getting the same answer as I did. The last problem on this set of notes is for us to graph this line, and hopefully with this line you've realized that it's written in point-slope form. So if it's written in point-slope form, there are a couple different things that we can do. We can first figure out what the point is that sits on this line, and that's pretty easy because all we're doing is working backwards from what we utilized before. The y-coordinate of the point would have been a -1, and the x-coordinate of the point would have been a -3. So that's my point, and then my slope from this line is 2/3. So I'm going to go to the point -3, -1, and plot it. So there's my point, -3, -1, and then I'm going to do a slope of 2/3. So up 2, right 3, up 2, right 3. Once you've got that, all you have to do is just draw a line through it, and you're all set. All right, make sure you have your whisk done for tomorrow, and we'll see you guys later.